Hi, I'm Lev, a PhD candidate at the University of Lausanne. I'm really excited to be presenting our paper, Designing a Data-Driven Survey System, Leveraging Participants' Online Data to Personalize Surveys. This project was done in collaboration with researchers from the University of Applied Sciences Western Switzerland and from the University of Maryland. As you know, online surveys are used extensively in the CHI community. Most of the time, we rely on general questions where every respondent gets the same questions. Likewise, we rely on self-reported answers about which services and devices respondents use. However, we may get more reliable and insightful answers by creating data-driven surveys. So, what are data-driven surveys? Well, data-driven surveys personalize their content and/or flow based on respondents' data. This is something we already do by using respondents' answers to previous questions. We focused on online platforms as data sources, such as Fitbit and GitHub. Henceforth, I'll refer to such platforms as data providers. Before designing a solution, we first did formative research. The goal of our formative research was to understand researchers' practices when conducting survey research and to identify any unmet needs that could be addressed with a data-driven survey tool. We started our formative research by conducting a systematic literature review of papers that used surveys. We narrowed our scope to studies about wearable activity trackers because we recently wrote a survey on the topic and fitness data sounded particularly interesting to us. We started with 689 papers. After applying our selection criteria, we were left with 74 papers. Then we analyzed the papers using reflexive thematic analysis. We found the following. First, with regards to platform usage, Qualtrics was the most frequently reported survey platform used, and Fitbit was the most frequently studied wearable activity tracker brand. Second, with regards to potential for fitness tracker research, most studies didn't directly use data-driven surveys. But there was a clear opportunity for using data-driven approaches to improve the reliability and depth of insights derived from fitness tracking studies. For example, by avoiding relying on self-reported data in questions like, how often do you exercise? Finally, data-driven surveys could improve survey quality. They could change abstract questions into concrete ones, directly collect data to save time, and avoid issues related to participant recall, and allow for easier and faster screening. Next, we conducted an online survey with researchers because we wanted to hear from them directly. In this survey, researchers were presented with 3 core features that we envisioned for our data-driven survey platform: customizing survey flow and logic using respondents' data, creating templated questions and answers, and creating custom variables that are made by selecting specific data using rules defined by the researchers. For each feature, we asked them whether they previously implemented them, how useful they would find them, how likely they are to use them, and what use cases they could envision for such a feature. If they previously implemented such a feature, we asked how difficult it was. If they had not, we asked why they hadn't. We then asked them to describe any pain points that would be addressed or benefits that they would derive from using such functionality. We recruited researchers by contacting the authors of the papers we reviewed from our literature review, using university and conference mailing lists, and researcher social media groups. In the end, we collected 52 responses from researchers with survey experience. Most of the researchers were either HCI researchers or usable security researchers. The majority of researchers reported that they would find each feature at least slightly useful, and that they would be at least slightly likely to use it. Overall, customizing survey flow and display logic was the most favored feature, both in terms of being useful and likely to be used. The researchers came up with a variety of scenarios for using the features. Some notable examples were customized data-driven questions in gaming research and studying developers' commit behavior. They thought data-driven surveys could help them to improve data quality, create new research opportunities, and enhance participant engagement. The researchers reported privacy and anonymity as critical concerns. Specifically, they emphasized The need to include privacy-enhancing mechanisms when designing and implementing data-driven survey tools. Based on our findings from our formative research, we started designing and implementing our data-driven survey platform, which we called DDS. Our goal was to create a platform that would be extensible and easy to use. It should enable integrating participants' data in online surveys, and it should allow researchers to use the 3 core features we asked about in our researcher survey. We included privacy-preserving features. You'll find more on that in the paper. My supervisor and I followed an iterative design process for the UI. We first started with sketches and then switched to using Figma to create mockups that could be iterated on more easily. Similarly, we used an iterative design process to design the software system. I proposed an initial system design, which was then iterated on by 4 authors. After converging on a system design, I implemented the system together with a software engineer. For the implementation process, we used an adapted Scrum approach, which is an agile project management system. Here's the overall architecture and functioning of DDS. Let's have a look at how DDS works. There are 2 key roles here, researchers and participants. Let's see how it works for researchers. The researcher flow begins by first creating a project on DDS, a separate website. Researchers can create a project from scratch or using an existing survey. When creating from scratch, DDS will create the survey on the chosen survey platform, for instance on Qualtrics. When using an existing survey, DDS will link to the existing survey. After creating the DDS project, the researcher can add data providers to their project. Data providers are the online platforms from which DDS will obtain participants' data. Let's add Fitbit as a data provider. To add a data provider, a researcher needs to register an app on the data provider website. Registering an app amounts to filling in an online form. DDS also provides information that is commonly required by app registration form fields. After registering an app, the researcher needs to copy-paste the required information in the Add New Data Provider window. Next, the researcher can configure the variables. Variables are what will be uploaded to survey platforms and will represent the placeholder values for participants' data. For example, this variable is dds.fitbit.builtin.activities.byfrequency1. It will represent the name of the most frequent activity done by a participant. Researchers can enable the variables they want to have available when creating their survey. For each variable, there is an implicit exists variable that has a .exists appended to the end of its name. This variable will be set to true if the base variable was defined successfully, otherwise it will be false. This can be used to easily configure display and skip logic. After enabling the variables they want, researchers can sync them to the survey platform. Researchers can create custom variables by clicking on Add Custom Variable. This will open a form where they can define their custom variable. Here we'll create a custom variable that will select the longest duration running activity within these 2 dates. After creating the custom variable, it will be available in the variables table. After syncing the variables, researchers can use them in their surveys just like they are used to. For example, with Qualtrics, the variables will appear as embedded data. You can use them for survey flow logic, you can use them as placeholder values and questions, and you can use them to configure display logic. You can preview the questionnaire and export respondents' data directly from DDS. Variable placeholders will be replaced with respondents' data. The participant flow begins with the researcher sending them the survey distribution link that is available at the top of the project management page. After opening the link, participants arrive on this page. Here they can view a table that summarizes the data that will be collected from them, for transparency reasons so that the consent is fully informed. There is also a link to the privacy policy. Participants need to authorize access to their data for each data provider to be able to take a survey. After granting access and clicking on Proceed, DDS will download only the data it needs to compute the variables. It will then upload the variables to the survey platform and then delete the data it downloaded. Then, it will generate a unique distribution link to the survey and will redirect the respondents to take it. Here is how the survey we defined previously will look like for a participant. In terms of future work, we plan to continue developing DDS and to evaluate the usability and acceptability of our platform. With researchers, we will study the usability, and with participants, we will study whether they would be willing to take data-driven surveys. To access our paper, you can use the QR code shown here. Additional resources, such as a demo video, can be found on OSF here. The source code for DDS is available on GitHub through this QR code. If you are interested in using DDS, please do not hesitate to contact us using the email shown here. We really hope to build a community around the use and development of DDS, so we're really happy to help. Thank you for listening and watching, and we're looking forward to collaborating on DDS with you.